together, we put together this presentation that introduces terms related to data sets. Okay, so given that Power BI has undergone such change over the past 6 years, that data sets are much more than what people think they are. Well, that's our experience anyway. So it is my intention that in this presentation, that whether you're a beginner or even if you're an advanced Power BI practitioner, there'll be something to learn about what data sets really mean in Power BI. So I know Suresh has already introduced me, but my name is Peter Myers. Yes, I come from Melbourne. I'm a specialist in Microsoft Data Platform with a focus on business intelligence. And I've spent the past 20 years of my career evolving alongside Microsoft and their data platform. I'm going to introduce Chris as well. While he's not co-presenting with me, he's been part of the brain power that has put this presentation together. All right, it helps for me to understand a little bit about who you are. So what I'm going to do is put up here a survey, and then I'm going to invite you to use the URL, or what I'll do is open up the chat window and paste the URL in for you. And just take a moment to click on that link, complete some fairly simplistic questions, and then real time, we will see details about who you are as an audience. And then I'll be able to best pitch this presentation to you. Alrighty, so we've got one ninja, 2 ninjas in the audience. Oh no, Jedis, I think was the
right.
Those with an experience of 9. Okay, maybe at the end of this session, you might rate yourself as a Jedi. All right, and someone at the 1 level, so someone with, probably new to Power BI, welcome. And you'll find that the very first topic that I introduce will be the fundamentals, like what is a data set? And then I'll build up to increasingly more complex topics on what data sets can be. So thanks for participating in the survey. What I'm looking for here is what the role is. In fact, the top 2 roles are ideal, because when we talk about data sets, and more specifically, how we're going to create or manage or optimize those data sets, we're really talking to BI developers and business analysts. So welcome. And from an experience point of view, very happy to see across the board. We've got people with very basic skills right the way through to Jedi experience. Now, there was an additional question that I've asked you, and that was, what is the most important topic for you today? So we'll certainly be covering off on optimization and fundamentals, I've already mentioned, and model frameworks are the top 3 topics that will be covered in the presentation today. All right, well, that gives me a good idea about who you are as an audience. So let me switch back to the presentation. And now it's a matter of just working through the agenda, which has been broken down into these groups. Now, time permitting, and Suresh, could you remind me how long can I talk for? Because I can talk forever, but I do know that people have lives to get on with. So let's put a time in mind where you would like me to wrap up and draw a conclusion.
Right, about an hour to an hour and a half, Peter.
All right, so let's aim for an hour. And I welcome questions, but what I found is best for this presentation is that you keep those questions till the end. Feel free to post them in the chat window as and when you have them. And at the very end, I'll come back and circle around on those questions. So the best place to begin on this presentation is with fundamentals. So let's begin with the definition of the data set itself being a Power BI artifact that represents your source of data. Now, when you understand that Power BI is a data visualization service, obviously data is an important element of visualization. So the data set is that artifact. Without a data set, there is no data to visualize. Now, a data set is stored in a Power BI workspace. Let's see by example. So here we have workspace A that has data set, and it has 2 reports and a dashboard. This is a fairly standard approach, but workspace B has its own data set, but I want you to notice that report B1 uses dataset A1. So there is no requirement that the report needs to belong to the same workspace. Now, in fact, in the newer Power BI service, when you open up the Datasets hub, you will get to see all of the datasets that you have permission to work with. So you don't need to open up individual workspaces anymore. And then you can go ahead and create reports based off any of those datasets and save them to the workspace of your choice. All right, now you may be familiar with this furry creature, and I'm referring to the one on the right. His name is Paginated Reports Bear, and he's the mascot for Paginated Reports. And he's just raised an interesting question to Chris. And he's saying, but hold on a minute, Datasets is used somewhere else. And in fact, if you're familiar with SQL Server reporting services or the newer generation being Power BI Paginated Reports, you might be familiar with the concept that we have datasets here. The fact is these are very different concepts. So the dataset that you have inside a paginated report is basically a query on how to retrieve data for the purpose of rendering a report. It is very different to the dataset that we're talking about in Power BI, so do not mistake them. Moving forward in this presentation, I don't talk about paginated reports anymore. But just to make things a little more interesting, is that when you add a data source to a paginated report, it can be based on a Power BI data set. All right. So the next term in our fundamental section is the term of data model. And a data model is basically a queryable resource optimized for analytics. And what do we mean optimized for analytics? I'll come to that in the next term. But Microsoft have developed their own technologies for analytic data models. And these data models can be queried either by using DAX, data analysis expressions, or MDX, multi-dimensional expressions. Sometimes these data models are referred to as semantic models, or more simply, especially in the context of a data discussion, they're simply referred to as a model. Now, with a focus on how data models are queried, it's important to understand that there's this concept known as an analytic query. And in fact, it has these three phases whereby the query will filter and then group and then summarize. And that's the specialty of what Power BI does when you think about it, that every visual that you put on a report page most commonly is filtered, usually is grouped by something, and then there's some summarization that happens. So let's see by example. If I were to give you thousands of rows of data to say, look, here are all of the sales orders, that's a good starting point, but it's not going to directly support you when you have a question like this. What were the quarterly sales that were made in 2021? The way to answer that question is that you do need to perform a filter and a group and a summarize to arrive at the answer to the question. So let's see how Power BI might do this. The filter could be achieved through a slicer on your report page. All right, so we focus on a subset of all of that data only for the orders that were created in the year 2021. And then we might add a visualization like a column chart. And on the axis, we would put the quarters, thereby we're grouping by quarter. And then the value of the column chart would be a summarization of the data. In this case, the sum of the sales amount. And that's effectively the pattern that takes place for every visual on every report page that you see. So it helps to think that when you're configuring these visuals, that you're filtering, grouping, and summarizing. Now, the next term is a specific type of data model. So bearing in mind that Microsoft have DAX and MDX, the M in MDX stands for multidimensional, and its origin was cubes or multidimensional models. It was in SQL Server 2012 that Analysis Services introduced the tabular model, which, by the way, first came through an add-in in Excel known as Power Pivot, and has later become Power BI's engine. So the tabular model is a very specific design approach whereby the fundamental object in the model is a table. And of course, tables comprise columns and represent rows of your data. Now, in addition, the tabular model can be enhanced with relationships and hierarchies and levels and calculations. So do note that all models in Power BI are tabular. When you create them, you're going to use Power BI Desktop. Now, this isn't just a data modeling tool, it's also a report authoring tool, okay, where the report can connect to a data model and visualize the data. But our focus in this discussion on data sets is the data model itself. Now, as a tabular model, where do those tables come from? And this is where Power Query as a technology comes in. It allows you to connect to a broad array of data sources and then to use a formula language known as M to create queries that output tabular objects, columns and rows of data. Now, when those Power Queries are applied, they become tables in your model. So that's primarily where tables come from. But the complete picture is a little more interesting because we can also use DAX as a formula language to add columns to a model. Now, a big difference here is that DAX cannot access external data. Only Power Query can connect to external data. So DAX can use functions that might create a series of data like dates, or it can transform data that is already loaded into your model. Regardless of where these tables come from, this is the foundation of your tabular model. These tables comprise at least one, but possibly more columns. Those columns can be added through DAX as a calculation. And where you have more than one table, you can create relationships between them. And that's important because these relationships support filter propagation. More on that topic in a minute. You can enhance your tabular model with hierarchies, and these hierarchies have levels. They're basically a sequence of columns from the same table that allow ease of navigation from higher level to lower level, like year, quarter, month, and day. And the last object that I'm going to build up here is that your summarization, remember, filter group summarize is the analytic query. Your summarization is achieved through measures. Now, measures are formulas that achieve a single value result by typically summarizing multiple values. So these are the very basics. And for a beginner, this is your starting point, that you need to become very familiar with these objects and how to design the correct model to meet your requirements. I'll come back to this diagram when we involve more complex topics. Now, another term Chris and I debated we needed to include in this presentation was that of star schema. So the star schema is in fact a mature modeling technique used by relational data warehouse developers like BI developers. And their job is to compose a model with tables consisting of fact tables and dimension tables. Now, a lot of the theory for star schema is relevant to Power BI desktop data modeling to produce intuitive and optimized models. It then asks you to consider what role does the table play? Is it a dimension table that represents an entity? Maybe it's a product or a place or people or a concept like date. Or is it a fact table that represents the business activity that you're measuring and reporting on, like the sales orders? Ultimately, you will create those tables that are dimension and fact in your model. And this is where it's interesting, is that I've mentioned the analytic query. And so these dimension tables are for filtering purposes and for grouping purposes. And then when it comes to the summarization of your data, most typically it comes from your fact tables. Okay, so there are many important concepts that we would like you to be aware of in star schema design. Obviously, dimension and fact table is the basic, but next level of complexity is to understand granularity and dimensionality, and that will help you with configuring relationships and for defining calculations. You might also need to create surrogate keys because relationships in Power BI models are single column relationships. And also the concept of measure is one that you need to be familiar with as well. And I'll use this opportunity to do a bit of a marketing plug for some Microsoft documentation, like an article called Understand Star Schema. So let me do this. Let me go ahead and copy the link for that, and I'll actually share it in your chat window as well. And what shall I do here? I've just opened up the article, right? So This is a great article if you're new to Star Schema because it provides you with an overview. What is Star Schema? What are dimension tables? What are fact tables? And why is this relevant for you in Power BI? And then as and when you're ready, you can continue to read through more advanced topics. And especially if you're a BI developer that is already familiar with Star Schema, then this is a very quick way to understand how Power BI tabular models could be optimally developed. All right. So in fact, the article was written by me. So I've been lucky enough to be engaged by Microsoft over the past couple of years to build out their guidance documentation on Power BI. And this was one of the first articles that I wrote because it seemed like a good starting point. Also, from my experience as a consultant and teacher, was that this was a big knowledge gap for people, and I could see some really poor designs surfacing and problems as a result of those designs. And I'd come in and help, and I'd say, all right, you need to understand what a dimension table and a fact table is to help build out this model. All right, next definition is that of field. And so in fact, a field isn't a data modeling term. It's a collective term that represents 3 different types of objects in your model. So it's relevant at report authoring time. What that means is that when you look at the fields pane, you will see that columns, levels of hierarchies, and measures are all collectively known as fields. So essentially, these are the different types of model resources that you can use to configure your visuals in Power BI reports. Okay, so field is not a term that we use in a data modeling conversation. It's a report authoring concept. And then the last fundamental term is in fact another Power BI artifact, being a data flow. And Chris especially, because it's one of his specialties, but he's noticed a lot of confusion and a lot of misunderstanding about data flows. You see, people think that in Power BI, when you have a report and a data flow, well, the report could query the data flow. And the fact is, this is incorrect. The data flow is in fact a fragment of data that can only ever be used by another data set. How does this work? Well, we would open up Power BI Desktop. Remember, it's a data modeling tool. And we could import data from the data flow and potentially other data stores. And we could create our well-designed model. And when we save and publish that back to the service, it results in a data set. Okay. So then at that point, the data set could, under a scheduled refresh, maybe once a day, could refresh the data from the data flow. And then the report could query the data set. So when you think about data flows, if you're a BI developer, you can think of them as your staging or your master data, okay? They can also be used in a variety of ways, but what matters most is that you can control that you have a single version of truth, and it's especially relevant when there are multiple data sets that need to reuse the same data. And I think product is a good example, that if we have a master data flow defining product, we could potentially have, a dozen different data sets that use product as one of their dimensions. And therefore, for consistency reasons, they all refresh from a data flow. All right, well, that gets the fundamentals out of the way and has a very clear definition on what a data set is. So the next level of conversation is, but where is the data model hosted? And so the fact is that models can be hosted internally, but also externally. And an internal hosted model is just like this. The model is within the Power BI service, within your tenant. So for any model that is developed in Power BI Desktop and then published to Power BI, well, then it's an internal hosted model. Yet Power BI has the ability to connect to external hosted models. These are hosted outside Power BI, and there are 2 options, either Azure Analysis Services or SQL Server Analysis Services. All right, noticing that for SQL Server Analysis Services, there is the ability to connect to multi-dimensional models if you have these cubes. Now, to achieve this, Power BI does what is known as a live connection. So let's see. The first example here in Dataset A is that it's connecting to Azure Analysis Services. And this is a very strong combination, especially when your Power BI tenant and the Azure Analysis Services resource reside within the same data center. Dataset B is connecting to SQL Server Analysis Services, and note the requirement to have a gateway to support the secure communication of data flowing from the service to on-prem and then back again. Well, let's focus in more detail then what is meant by live connection. In fact, it is an overloading of definition here that Microsoft use it in two different ways. First of all, when you're authoring a report in Power BI Desktop against a remote data set, or as just explained, a data set is connecting to an external hosted model. So let's see by example that if you're authoring a report and the data set already exists in the Power BI service, then you open up Power BI Desktop and you do what is known as a live connection. In fact, if you look at the bottom right-hand corner, there's a status in Power BI Desktop that says you are live connected to dataset ABC. You would then go ahead and produce a beautiful visualization of data, and then you would save and publish that to result in a report that is connected to that data set. At that point, it's not really a live connection anymore. So it's a report authoring concept, and certainly it's a mode in Power BI Desktop to author against a remote model. But just as a reminder, live connection also means that a data set is live connecting to an external hosted model. Therefore, the report queries the data set, but ultimately queries are redirected to the external hosted model. All right, next grouping is real-time analytics. So you might be aware that Power BI can deliver near real-time results to Power BI dashboards, but also to Power BI reports. In fact, this is a screenshot of a Power BI report that is updating on a second frequency. There are special types of data sets that achieve this. So streaming data set is a special type of data set that is only supported by streaming tiles in a dashboard. So Power BI reports cannot use this type of data set. It is a very different technology. In fact, there is no data model in the way that we think of a tabular model. And it will cache data for up to 60 minutes, and it will provide very fluid real-time visualizations in dashboard tiles. Now, a second type of real-time data set is the push data set. And it's very closely related to the tabular model that you can develop in Power BI Desktop. However, you cannot create push data sets in Power BI Desktop. You can create them in the Power BI service, or a developer can programmatically create them by using the Power BI REST API. Now, if you bring streaming and hybrid together, streaming and push together, you end up with a hybrid data set. So a hybrid data set is both streaming and push at the same time. Now, when you open up the Datasets hub in the Power BI service, you're presented with a list of all data sets that you have permission to work with. Okay, but there is no special icon or description that says what type of data set it is. So either you need to know, or you need to refer to documentation, or perhaps the name of the data set provides you a clue. So let's just, for revision purposes, let me explain that the per capita sales is an internal hosted model that was published from Power BI Desktop. Yet the finance cube is external hosted model using a live connection to SQL Server Analysis Services. In fact, the word cube is a giveaway that it's a multi-dimensional model, and the only option to host a multi-dimensional model is SQL Server. The call center operations is a push data set, the foreign exchange rates is a streaming data set, and device telemetry is hybrid, with those last three all being real-time data sets. Now, for completeness on the topic, those data sets support real-time dashboards, but in more recent updates to the product, we have a feature in Power BI reports known as automatic page refresh. It is a property at page level on a report, enabling a refresh to happen on a fixed frequency, maybe once a second or once a minute or once every 30 minutes. It is driven by the fact that your data set is using a direct query model. And we're going to talk about direct query models next. Okay, and I'll remind you about automatic page refresh at that point in time. Now, I could talk in more detail about real time, but it's not really the entire focus of today's presentation. It just so happens that Miguel Martinez and myself produced a 1-hour webinar recording for Microsoft that covers off on all of the topics about streaming and push and hybrid and automatic page refresh, and that you're welcome to register for this presentation at no cost. Okay, and it's included with many demos. So this presentation at the end will be available for download. And when you download it, the link that I have here for you is clickable. So that concludes the topic of real-time analytics. And then it brings us then to perhaps one of the bigger areas for discussion, and certainly where we find a lot of confusion or misunderstanding about what you can do as a data modeler. So the opening term to discuss here is that tables in a tabular model have a property known as the table storage mode, and that you have 3 options: import, direct query, and dual. All right, so what it means here is that tables that are added through Power Query, okay, have a storage mode that you can configure. It does not apply to calculated tables. The 3 options, import, direct query, and dual, mean this. Import means that the table physically stores the data. It is loaded in, whereas direct query says the data remains in the data source, and when Power BI queries the table, then a query is sent to the underlying data store. And dual says that it's both, and Power BI will choose the most efficient storage mode for the purpose of the query. So it means that the table still loads the data, but there is the potential that Power BI might query the underlying data source instead. And we'll talk about dual storage mode in the next section on optimization. In this setting, we will talk about import and direct query frameworks. So that leads us to the next term of what is called an import model. So an import model is defined by one where every table is using import storage mode, or it has calculated tables. It is the most frequently type of model that is developed. So let's see by example. And notice here that as I begin to import more and more data from different data stores, that star is growing larger, representing more volumes of data being imported. Notice also that the different types of data sources represent different data formats, because it just doesn't matter. Once the data is imported into the table, the format is irrelevant. So therefore we can integrate data from different sources and indeed from different formats. Now in Power BI Desktop, the way that we do an import, in fact, you don't have to try very hard because it is in fact the default. That some data source types like SQL Server support both import and direct query connectivity. And where both are supported, import will be the default. So you may not have even noticed this. Now, import is a good default for many, many reasons. Now, when we consider the benefits of import modeling, there is no restriction to the data source type. In fact, all data sources support importing. And therefore, we can import from multiple sources, achieving integration within the model itself. I could bring in data from my organizational systems, and I could bring in external data from a web page and integrate them into a single model. When it comes to the flexibility for a modeler, we have no restrictions on the DAX functions or the M functions that are used. There is support for calculated tables, and it delivers the best query performance. And why does it do this? Because when data is imported into tables, it is compressed and it is optimized and indexed for highly efficient filtering, grouping, and summarization, right? It is optimized for analytic query workloads. Now, while these are compelling benefits, there are limitations. And the fact that we're importing data and that storage space or memory where these models must be hosted isn't infinite, then we do have limitations. And the general limitation is that your model cannot exceed 1 gigabyte in size. Now, by the way, 1 gigabyte is massive. The compression that is achieved on average is usually about 10x, which would mean if you had a model that was 1 gigabyte in size, you probably had around 10 gigabytes of source data. Now, 1 gigabyte is the general limit, but if you're working with premium licensing, then that can grow to much larger sizes. Now, the other consideration is that that data in your model is only as current as the last refresh that succeeded. And Power BI will impose limitations on how often that can refresh, whether it's 8 times a day or with premium up to 48 times a day on schedule. So if you have need for the most up-to-date data, then import might not be the right mode for you. And the other consideration is this, especially for large data models that take a long time to refresh, and they also put pressure on the source systems that must be queried, is that large tables need to begin again. They need to remove the data and then reload everything unless you're going to work with advanced features like incremental refresh. We'll talk about it later as well. All right, so huge benefits for import modeling, but on the other side, limitations you must plan for. Size limitations and the latency factor of how old or how stale the data is coming through on an import model. Now, it leads me to point out another article. In fact, I think it was the second article that I wrote, Reduce Data Model Size. That when you're doing import modeling, we want you to be conscious of the fact that you should be efficient at all points in time and therefore make design decisions like remove unnecessary columns or unnecessary rows or achieve a higher level granularity by grouping and summarizing and loading that result into your model. So please do check out this article, because what may not appear as an important priority today could be a big pain for you in 10 years' time if it's still your responsibility, because that model might have accumulated so much history but was inefficiently storing it or unnecessarily storing it that it can't be refreshed any longer, all right, which would force you to make some hard decisions like remove history or re-architect the model so that it remains under 1 gigabyte. And therefore, the re-architecture of the model might mean breaking reports and redesigning them, okay? Of course, the other option is that you could go and ask for some licensing and move to premium so that that model could continue to be hosted. But if I'm spending extra money on licensing, I'd want to make sure that I wasn't doing anything inefficient that could be solved more easily and quickly and more economically. All right, that's the discussion to be had about import. For this reason, we see most customers today are building import models. And I remind you, it is the default behavior in Power BI Desktop to do this. Yet, we understand that table storage allows us to use direct query. And so we'll introduce the next term, that is direct query model. And a direct query model is where all tables use direct query storage to a single data source. Okay, so in this example, we can see we've got our model, and it queries, in this case, an Azure SQL database. But notice what happens here, that when the report visuals query the model, then they are passed through to Azure SQL because no data is actually loaded into the model. Now, when you connect to the data source like Azure SQL, you will need to intentionally select the direct query connectivity mode. And the two compelling reasons to do this are that you have large volumes of data. In fact, so large that it's either impractical or impossible to import that into a model. And the second compelling reason to consider direct query storage is that you want real-time reporting. That 8 times a day refresh isn't frequent enough for the volatility of data that we have. So bear that in mind. You will use direct query for volume or velocity. Now, there is another interesting scenario that is a very recent consideration due to a preview capability that we now have that says that we can also direct query to Power BI datasets. So bear in mind, direct query is supported for pretty much all popular enterprise relational databases. So that would be SQL, Azure Synapse, and then you've got the competitor products of Microsoft like Oracle, DB2, and so on. But now direct query in preview, if you enable it in Power BI Desktop, allows creating a direct query model over a Power BI dataset. Therefore, it opens the potential for model personalization, and model extensions. We'll come back to that point shortly, okay? But the takeaway at this stage is that direct queries benefits are volume velocity, but limitations you must be aware of, and that is that not all data sources support direct query mode. As I've mentioned, popular enterprise relational systems. The queries that you develop in Power Query cannot be overly complex because they must directly translate to a query that Power BI can send to the underlying database. Reports that use direct query models can be slow because of the time involved in sending every query and then waiting for a response. And this is especially the case where the data system was not optimized or is insufficiently resourced to handle the workload that Power BI imposes over the database. So for this point, I do like to raise a word of caution that if a database owner gives you read permission to read the data, they might give that to you on the understanding that once a day, you're going to query the tables to refresh data in your import model. If you change it to a direct query model, they may not be prepared for the thousands and thousands of queries that are going to be sent to the database, potentially interfering with its ability to focus on what the database was designed to do. For example, it was designed to manage customer sales orders. All right, so just be aware that if you're going to create a direct query model for a valid reason, volume or velocity, that you engage the database owner in a discussion to ensure two things, that they optimize the database for you and they ensure that there are sufficient resources to handle the estimated workload that Power BI will place on their database. All right, so we move to the next term because things can get more interesting, and that is you need to understand that there is this concept of a source group. And a source group is a set of model tables that are related to a data source. Now, there's a special source group known as the import source group, that all data that is imported in addition to calculated tables are stored inside the import source group. And should you connect to a direct query source, then every direct query source is its own source group. You might be familiar with this term already. Microsoft recently relabeled it, but it used to be known as Data Island. Okay, so now it's source group. So let's see what this means for us as data modelers, that we can have a model where some tables are import and some tables are direct query. That would mean we have an import source group and we have a direct query source group. Now, what I'm introducing to you now is a new term, composite model. And a composite model is one where there is more than one source group. So I've already introduced import model. There's one source group being an import source group. A direct query model is a single source group direct query, so one data source. Composite says you have two or more source groups coming together. Now, by the way, that could be an import source group and a direct query source group, or it could be two direct query source groups. One connects to Azure SQL, one source group connects to Oracle. So let's take a look at an example. And here you can see a model diagram in Power BI Desktop. And what I'm pointing out to you is that the two tables, date and journal, you'll notice that they do not have a blue bar across the top. Yet the scenario amount, and account tables have a blue bar. What that indicates to us is this. In fact, if you hover your cursor over the date table, a tooltip will reveal to you that it is an import storage table. And if you hover over the scenario amount, you'll see that it's a direct query table. So the colored bars indicate two things. They indicate you're in a direct query connectivity, and the color means that tables with the same color belong to the same source group. In other words, they're connecting to the same underlying source database. All right, so there is a visual indicator that helps you understand the source groups in your model. Now, the next concept is that Power BI Desktop has a mode. In fact, if you look at the bottom right corner, you might see a mode, or in this case, you might see nothing, and nothing actually means something. So there are, in fact, 4 different modes: live connection, nothing, direct query, and mixed. What live connection means is that you're connecting to a remote model. All right. Therefore, the model framework could be anything. It could be import, direct query, or composite. And there could be one or more source groups. If it's nothing, it means that you are working in an import model. You have a local model in Power BI Desktop, and it consists of a single source group, and all tables are import storage mode. If it's direct query, this is where things are a little tricky. What it's telling you is that every table is using direct query storage, but not necessarily to the same source group. Therefore, it could be a direct query model with a single source group, or it could be composite, composed of multiple direct query source groups. Lastly, if you see mixed, what Power BI Desktop is telling you is that the storage modes are mixed. There's some import and there's some direct query. So we know for certain that it is a composite model, and it certainly includes an import source group and at least one direct query source group, but it could have more. All right, don't get too caught up on this. Power BI Desktop mode is sort of a different way of thinking about your model, but what really does matter is the framework, import, direct query, or composite. So let's come back to this diagram and understand it in a little more detail. All right, so in review, we know by looking at the tables that we can determine the number of source groups. But date and journal do not have a colored bar, import source group, and we see just one other color. So therefore we know there are two source groups. And next, for model framework, it's composite because it's composed of more than one source group. And then desktop mode, because there's import and direct query, then it must be mixed. And then the question about how many data sources, in fact, is a trick question because the model diagram cannot tell you simply because there's an import source group. And the only way to answer the question is that you would need to open up the Power Query editor to look at the sources that contribute to those tables. I can tell you, though, that the answer is actually one, which might be a surprising answer. Why would we have a single source where some of the data is imported and yet some of it is direct query? And the answer is, and it's a real world example, is that this is a financial model, and the journal table stores general ledger transactions and all of the history, and it's refreshed once a day at 6 a.m. in the morning. And yet the financial controllers do modeling with budgeting and forecasting. And when they revise budgets and forecasts, they don't want to have to wait till 6 a.m. in the morning to see how that looks into the future. So when they write back these values into the Azure SQL database and they refresh the Power BI report, they can instantly see forecast and budgets updating immediately, right? So the whole design of this model was to drive real-time scenario values over the imported data representing the history of general ledger transactions. All right, so as a modeler, it gave me choice to bring the best of both into producing an optimal and useful model. The next term is that models are either local or remote. And what local means is that it is local to the report or whatever is querying it. So if you're in Power BI Desktop and you're authoring a model, that model is local to the report. Now, a remote model says the model is not local. So think about it. If you do a live connection to a data set, then the dataset model is remote from Power BI Desktop. But the reason that this term becomes important to understand is that we now got a new capability with direct query mode. As I mentioned earlier, direct query can be used to create a model off an existing Power BI dataset. And therefore, we have two models. We have the new model and we have the remote model, right? So local, remote. Let's talk about it by example. All right, so in this example, this company has what it calls a core model. The IT department and the BI developers have produced a model over, it happens to be Azure Synapse Analytics, a direct query model. And this is a certified data set that allows people to produce, single version of the truth reporting over the company's main data subjects. Now, a business analyst has been tasked to create a new report known as per capita sales. And so the analyst creates a live connection, right? So remember, this is a report authoring mode. And yet, when the business analyst looks at the model, they do not find population to support them in the sales per capita report. So what they can do with this new preview feature is they can switch the live connection into a direct query model. So now in Power BI Desktop, we have a local model and the remote model is in the Power BI service. Having switched it to a direct query model, that allows the business analyst to do something really interesting. Look at this. The population data that the analyst needs comes from a web page. So by importing this data, a new source group has been added to the local model. And now with this new table, the analyst can create a relationship to integrate the data between the import data and the dataset model. Now the analyst produces the report with sales per capita and lovely maps and visuals, and then publishes that solution back to the Power BI service, resulting in two things: a new data set and a report. All right, so this new data set is like a specialized version of the core data set. The specialized data model, therefore, is local and the core model is remote. Now, that introduces the last term, chaining, because what that means is that the specialized model is chained to the core model. And in fact, Microsoft will allow you to chain an additional data set, that you can have a chain length of 3, something like this. Now, what does that mean when report B queries dataset B? Well, dataset C has nothing to do with this, but dataset B is considered local to the report and dataset A is remote. And if we have report C, then we'll see that dataset C in this case is local and datasets A and B are remote. Okay, so this is a very exciting technology and it solves a very important problem, because if this capability was not available, and in fact for many years it hasn't been available, and it's been a source of frustration for people like myself, that this simple requirement to bring population into the data set has meant either convincing the owner of the data set to make a change, which for such an important certified data set might require weeks or months of work and approval for that to happen, or the alternative is that the business analyst would completely recreate the model and therefore introduce duplication of effort and data and calculations. And it's what we call multiple versions of the truth. All right, so this newer ability to create new models that specialize other models is going to help avoid duplication. But you must use it with care, because the very tight relationship here, that in dataset A, for example, if I rename a table, then dataset B and dataset C are broken. If they build dependency on that table, it is broken, right? So you must be very, very careful with this approach to only allow it to happen, or to manage change in a very controlled way. And by the way, we can do that in Power BI by saying, what are the related artifacts to dataset A? And Power BI could inform you that dataset B is a related artifact. Therefore, before you implement change to dataset A, you should make sure that you speak to the owner of dataset B and the dependent reports as well. All right, so that concludes the big discussion on frameworks. Really, the discussion there is direct query versus import and composite modeling, and that capability to create chains of models local to remote. So the next set of discussion is around optimization of these models. And so it introduces the term of partition, right? So a partition stores import data for a table. And as it stands, all import tables have one partition, but there is the potential to add additional partitions. And therefore, when it comes to reloading data into the table, we can do it at partition level. And this is especially relevant for large tables, that it's very inefficient to reload all of the history every time. Okay, so partitions achieve this for us. And therefore, what you'll find is that partitions for import or dual storage tables can be created. Now, to do so, you would need premium licensing and the XMLA endpoint. Now, if you have the XMLA endpoint, you can connect to your dataset using a tool like SQL Server Management Studio. And thereby, in Object Explorer, you can open up your dataset, look at the tables, and manage the partitions for a table. And this is where you could go ahead and create or edit or even delete or process the data inside your partition. Now, for each partition then, and if you use a tool like Tabular Editor, you can see the M query that is used to load data for that partition. And I want to call out the very important filter here that ensures that into the partition for Internet Sales 2021, there is a filter here saying only load orders that have an order date that belongs to that year. Now, a very new term that we added recently is hybrid table. This is very, very interesting, and it's a coming soon feature, which means it's on Microsoft's roadmap. It's been announced, but there is no preview capability, not yet anyway. What it means is this, that storage mode that I introduced to you as a table level property now becomes a partition level property, which means that a table can have partitions with mixed storage modes. See, the example here might be that we have our history right back to 2011 is in import storage mode. We never need to process it again because we know that history will not change. But the most recent time slice partition is in direct query, meaning that any query sent to this table will deliver up-to-date data and full history. Now, another strategy might be, because that's such a volume of data, let's use the history in direct query as well. Because, the very old history is rarely queried, but if it is queried, it'll be slow, but it happens so infrequently it doesn't matter. And maybe more recent history would be imported, and then the most recent data could be direct query again because we want the most up-to-date data coming from the source. Okay, so these new hybrid tables, when they become available, provide you even more flexibility within a table itself to mix the storage modes. The next topic is dual storage mode. So you've learned that for a table in your model, it can either be import storage or direct query, but dual meant that it could be both at the same time, which means that Power BI has the ability to determine the most efficient path. In fact, what it would do is it would always choose import if it could, because it delivers the fastest query performance. So let's understand how it works. But the first thing I want to point out is that some changes have been made to my model. And what you will notice now is that 4 of the tables have a blue bar across the top and 3 of them are striped. The blue bar, of course, indicates they belong to the direct query source group, but the striped line indicates that they are both import storage and direct query at the same time. All right, when I hover the cursor over the account table, I can see it's dual storage mode. Now, does that mean the source groups have changed? No, there's still 2. It's still a composite model and it's still mixed mode and there's still 1 data source. So the only change is that 3 of the tables, and notably dimension tables, right, used for filtering and grouping of data, are giving Power BI the choice to use import storage or direct query storage. So let's understand how that might work for different visual requirements. Here, a visual that is reporting on current fiscal year expenses. To do that, the current fiscal year says there's a filter on the date table by year, there's a grouping on the account groups, and then we're summarizing the actual journals, right? So the journal table. What it means is this. These are the 3 tables that are queried. Notice that the fact table is in import storage mode. So Power BI will use the import store of the date and account tables to satisfy this query. There is no need to go to the underlying data system to query for this visual. But this time, this visual is filtering by the scenario forecast, okay? And therefore, it is using the scenario amount fact table. So therefore, it will use the direct query source group to satisfy this visual. In fact, if we were able to look at the query that Power BI would send to the data source, it would look something like this. You know, go ahead and group by account group, give me the sum of the scenario amount, join all of these 4 tables together, and then apply the filters of the year and the scenario. Okay, that's not exactly what it would do, but it's a close representation to what it would do. The important thing is it would not use the import source group. Now, the last example is interesting because it brings together actual and forecast. So in this case, all source groups must be queried, and the formula engine would combine the import result and the direct query result into a single result that then the visual would use to visualize the data. Okay, so the important takeaway is this: Dual gives Power BI the ability to determine the efficient path, and the efficient path will always be, where possible, to use the import source group. Notably, it is dimension tables that should be set to Dual. You wouldn't do this to the fact table because it probably defeats the purpose of why the fact table is direct query in the first place, volume or velocity, right? But for the dimension tables, especially for dimensions that are what we call slowly changing dimensions, this design works very, very well. Another term for optimization is aggregation. And an aggregation is a special table in a tabular model that is designed to accelerate query performance. All right, now let's see by example that we have a fact table called internet sales that is direct query. And the fact is that could be extremely slow. So what we've done is we've added a new table to the model, and notably it is an import storage table. And I want you to notice that the dimensionality is simple. The dimensionality is by order date key. So there is 1 row per date, and the second column just stores the total sales amount. So it's really just a summary. By day, what was the total internet sales? In Power BI Desktop then, we would manage aggregations on this table, and we would define what both columns truly meant. The first column, order date key, represents a grouping of the date key column on the date table. And the sales amount aggregated represents the sum of the sales amount column on the internet sales table. Now, this data is helpful because Power BI can then detect a query that is grouping by date key and summing the sales amount column, and it can redirect the query to use the aggregation instead of the true table. And when you manage aggregations, that table is permanently hidden. It cannot be used by calculations. It cannot be used by row-level security. It will only ever be used if Power BI determines that it can satisfy the query by using the aggregation. So let's see by example. A visual that says group by product color and filter by year and give me the sum of internet sales cannot use the aggregation because the aggregation does not have product key. Okay, so this would use the direct query fact table. Yet a second visual that says what were the sales by month for the current year can be achieved by the date table and the aggregation. And the date table being dual storage means it would use the import store, and then it would be able to sum the sales amount aggregated together. And so therefore we would get a fairly fast response from the import aggregation. Now, what's interesting about aggregations is that they only apply to direct query tables, right? You cannot put an aggregation over another import table. So where you have a direct query fact table, you can add an aggregation, and those aggregation tables themselves can be import or direct query. In this case, it is an import aggregation, but you could also have a direct query aggregation, which would imply that your data source has some optimized, summarized set of data. In SQL, that could be an indexed view. In Synapse, it could be a materialized view that is already storing summarized data to boost the performance of these types of queries. Now, another coming soon feature you should be aware of and was announced recently is that automatic aggregations mean that you don't need to create these tables necessarily. For Power BI premium hosted data sets, you can have a switch that turns automatic aggregations on and a slider that controls how much aggregation you might want Power BI to detect based on query patterns and to automatically create for you so that it can self-optimize. So stay tuned for automatic aggregations coming soon. Next topic, query caching. Another premium feature is you can enable query caching, and therefore Power BI can detect reusable queries and store the results, and therefore when it sees that the same query is being requested, it will just use the cache. And that completes the topic of optimization. We can now move on to the topic of refresh, which of course applies to import or dual storage mode tables. But how does this import happen? Well, it happens by the result of a refresh that is either scheduled, and shared capacities support 8 schedules per day for a data set, but premium workspaces would allow up to 48 scheduled refreshes to happen in a day. Or of course, they could be on-demand triggered or programmatically triggered. Power Automate can trigger a refresh, or if you have premium hosted models, the XMLA read-write endpoint would allow your own application logic to trigger a refresh of a data set. Now that brings us to the feature of incremental refresh. And now that you understand what a partition is, that this feature automatically creates partitions for your data set, providing you meet a certain criteria, that you must have date columns in your data source. And when you expose them in the correct way, you configure incremental refresh, and therefore Power BI will create and manage partitions, and therefore only process partitions where it detects data changes have happened. This can dramatically reduce the refresh time and reduce the burden placed on your source systems. Scheduled cache refresh. If anyone's using Power BI dashboards, what you should be aware of is that the tiles on those dashboards are actually using cached data. And when those visuals are based on import data sets, those caches update automatically when Power BI knows that a refresh is completed. So in fact, as soon as an import model refresh completes, it triggers the dashboard caches to update. But what does that mean if your data model is using direct query or it's a live connection to, remember, external hosted models? That Power BI doesn't know if the data is changing in the underlying systems. Therefore, there is a property on a data set that allows you as the data set owner to tell Power BI the frequency that it should update dashboard caches. It could be anywhere between 15 minutes or 1 week, and you would set it according to the volatility of the underlying data source. Next topic would be gateways, and gateways are relevant when Power BI needs to communicate with data sources that are on premises or they're hosted in virtual machines. So there are 2 types of gateways. The personal gateway allows a business analyst to install a gateway on their desktop, yet the standard is what administrators would install to allow the service to communicate with Power BI. Now, there's 2 reasons to do this. Of course, for refresh, if the data resides on premises, then you will install a gateway and create data sources that will connect to those stores. But remember, there might be external hosted models, SQL Server Analysis Services. The way that Power BI connects with live connection is via the gateway, or you might be using on-premises stores as direct query sources for your models like SQL Server. When you do set up a standard gateway, the gateway administrator will need to create data sources that are defined in terms of data source type, connection details, and the credentials that the gateway can use to authenticate with the data source. In addition, they can delegate permissions to dataset owners, allowing them to connect their datasets to the data sources of the gateway. All right, let me move on to security. And I'm conscious of time, so I'm going to be a little bit more brief. So dataset owner is a concept that every dataset has a single owner. And therefore, if you need to modify certain properties and you're not the owner, you may need to take ownership of the dataset. Just be aware that when you do that, any credentials like passwords that have been stored will be removed. You must reapply them if you're taking ownership of a dataset. The next topic is about permissions for datasets. All right, and there are three different permission settings. There is read, build, and reshare. Now, if you're a report consumer, that means you're just interacting with a report. At a minimum, you must have read permission on the dataset that the report uses. If you do not have permission to the dataset, then the report cannot query on your behalf. So read is required to read the data in the model. Build is a requirement if you're going to create a new report based on a data set, but also if you're going to do more advanced things like export detailed data from a visual, or use Analyze in Excel to connect with a pivot table in Excel to a Power BI dataset. You will need build privileges. Lastly, reshare says that you have the ability to delegate permissions to another user. The way that these permissions are assigned, they can be assigned expressly to the dataset, but usually they're inherited. And they're inherited either because you belong to a specific workspace role. That if the dataset is stored in a workspace and you're the admin or a member or a contributor, then you will automatically have read and build permissions. If you're just a viewer in the workspace, then you have read permission only. The other way that you can get permission to a data set is that you can have access to the app, and the app is using the data set. So automatically you get read permission, but it's possible that the app owner has also provided build permission, allowing you to create your own reports off the data sets. Gateways have permissions as well. There is the gateway admin that must be set up. And the next topic is data source, data permissions in the model. So back to this model diagram, it is possible to enforce what we call row-level security. That means that different report users see different data for the same report. The Australian salespeople only see the Australian sales, but for the same report, the United States salespeople see the United States data only. And that's achieved through row-level security by adding roles and DAX expressions that filter the data. There are static rules like filter by country as Australia or filter by country as United Kingdom. All right, and then you would map security principles like users and security groups to these roles. Or much more interesting is the dynamic rule by using the username function in DAX. And the username function will return the authenticated username, and providing your data model has that username stored in the model and you have the correct relationships in place, then you can have fewer roles that dynamically filter based on who the user is. Lastly, there are object level permissions. It is possible to permanently hide tables and columns based on who the user is. This would be applicable to highly sensitive data like a salary column in an employee table. However, it's only supported by Power BI Premium and analysis services in Azure or SQL Server. I'm running a little out of time. So what I'm going to do is just cut to the conclusion, but this deck is available for download. So for governance, natural language, and a couple of other topics in what's left, you'll be able to read through them yourself. So I'll arrive at the conclusion, which is resources. So first of all, we built this presentation, Chris and I, as a webinar recording for Microsoft. So if you would like to watch this recording again, or this presentation again, but from the perspective of Chris and myself, you'll be able to register to watch the webinar from Microsoft using this link. I acknowledge that a lot of content was covered in this presentation, but its intention was not detail, it was breadth. What are all of the concepts related to data sets, and what would I need to know to deliver the right data to my report users? So for deeper explanations of pretty much everything that's been covered, please refer to Power BI documentation. And certainly for guidance topics, as I've already introduced you to, is that there is the guidance section in Power BI docs, and you will find under the data modeling section, what is a star schema, how to reduce data for import modeling, how to configure relationships or troubleshoot them, when should I use direct query, when should I use composite, how can I build optimal and reliable row-level security. It's all documented here in good detail. Next slide is just marketing. It says, hey, that's what I do for a business, is that with my 20 years experience, I'm a consultant and a trainer, also a mentor, and I have comprehensive training content on Power BI that I offer on a classroom basis. So typically, if you've got a group of 4 or more that is looking for training, certainly feel free to speak to me. I often find myself customizing my content to fit the specific requirements of the customer. If they want to focus on direct query or they want to focus on DAX, then I can tailor a program to fit your needs. That brings me to the very last slide, which is that you've got the ability to download this presentation, and I'm going to copy the link into the chat window as well. And therefore, all of the definitions and examples are provided for you in a PDF document. And therefore, I've arrived at the presentation that I'd like to give, and I'm open for any questions that you might have. All right, Suresh, so I'm seeing, reading from the top, what is a supermodel? So, Dwayne, a supermodel could be the new ability to create a model using a direct query connection to a Power BI dataset. Think about it. It is a supermodel over an existing model because it is a more specialized form of it. So arguably a supermodel isn't the type that walks down a catwalk. It is the new capability for you to extend an existing data set with supplementary data or logic. Next question, Dwayne again, since I'm leaving early. Oh, so he's not here. I'd like to ask something that's bothered me since I've used Power Query. I get very excited about the concept of being able to build a star schema from a flat source like a denormalized set. However, I quickly realized that each query was pulling the entire flat source to build the dimensions. Yeah, so the answer to this is Power Query can't reuse across Power Queries. So what you might consider doing is creating a data flow from it, and the data flow does a lot of the data reduction, and then you would query the data flow to reduce it further. So look at data flows as a way of breaking down the complexity, but also the volume when working with a denormalized set of data. And there we go. And thanks, Pranam, for sharing that with Dwayne. From Carlos, in your experience, have any clients been able to use the concept of one enterprise semantic model, or do most have multiple? Good question. The reality is to create one big model is cumbersome and difficult for a team of people to do. So while you can create one big model, you might find it easier to chunk it down into subject-specific models. All right, so here's our sales, here's our manufacturing, here's our finance. And where you have repetition of dimensions, certainly date, but also product or employee, you might use data flows to actually create reusable sets that then can be accessed by the other models. All right, so you can strive to have a single one. What you've got to weigh up is what's this going to mean for the development team, but also the size of that model, and will it hit constraints like that 1 gigabyte if you're not relying on premium. Okay, so size restrictions, but also practical management of a single model might encourage you to break it down. And I think that's pretty much answered all the questions. So Suresh, what do you think?
I have one question from my end regarding the NLP, which is the topic we didn't get a chance to cover. Apart from the Q&A, any other elements that are part of that, Peter?
With Q&A, are there limits?
Right? When you said NLP, does that mean Q&A or something else?
Could you repeat the question?
Yeah. So in the slides, you have a bunch of topics, right? NLP is one of those topics which we did not get a chance to go through. So I'm trying to understand, what do you have as part of that NLP, the topics, right? Q&A is obviously one of the NLP capabilities, but are there anything else?
No, so Q&A is the feature, but linguistic schema is a way of enhancing Q&A. You can use synonyms in your model, but that's pretty much it. So there's not a lot to be said about it. And Q&A now works over direct query models as well. It never used to. So there's not a lot to be said. If you download the deck, you'll see that it's a fairly straightforward topic.
Sounds good. Anybody else has any final questions for Peter? Okay. I mean, this has been a great session, Peter. I mean, I learned a lot. I hope everybody else were able to benefit out of this. I'll definitely check out the rest of the topics as well. And, hopefully we'll have you back again in the future.
You're welcome. Well, I hope that you find this to be useful. Be sure to download the deck, and thanks very much for joining the presentation today.
Thanks again, Peter. Have a good rest of your day.
You're welcome. Good evening to you there.
Yeah.
Bye.
Thank you. Yeah, bye.